If you look at your review sheet, you won't see these specific problems, but you'll see 1 and 2 look like my first one. They're already factored. 3, 4, and 5 all look like the very simple factoring number 2. 6, 7, and 8 look like the little bit more difficult factoring where you have to multiply across. And then 9 and 10 is not equal to 0 yet. And so these are the 4 types of problems that you have on your review sheet. We're going to do these 4 problems, and then y'all can start working on the first page of your review, solving by factoring. And then we're going to stop a little bit ways, and we're going to do some quadratic formula ones, all right? So the first page is solving by factoring. If it is already set up factored for you, it's very simple. You're going to set each factor equal to 0, and you will solve. All right, so in this case, obviously, we're just going to add the 6 over. N can equal 6. Add the 4 over. N can also equal 4. And so that would be our answer for number 1 here that I've given you, 6 or 4. All right, if it is not factored for you, there are different ways of factoring. All right, if it just has a 1 in front, we just have to look at the last number. If it's like number 3, we have to do the multiplication across, or we have to pair it up. And so for this one, it doesn't have a first coefficient, it's just a 1. So we just have to look at the 10. Factors of 10 that add up to 7, that's going to be 5 and 2. So my factoring looks like this, m plus 5, m plus 2. And now this looks just like the first one. We set each factor equal to 0, and we solve. So in this case, m can equal -5, or m can equal -2. So same concept, you just have to factor first. This third type, it is equal to 0, which is what we need. However, it does have a coefficient in the first place other than 1. And so the method that we used last chapter was to multiply across. I think your handout called it the rainbow. So 3 times 3 is 9, or 3 times -3 is -9. We need factors of -9 that add up to give us -8. So we're going to use -9 and +1. Those will multiply to give us -9. They will add to give us -8. And then we are going to rewrite this middle term using those. We're going to say 3n squared, and we're going to use our minus 9n plus the 1n, and then leave the -3. And now that we've broken it into 4 terms, we are going to factor by grouping, all right? Grouping. And so we're going to group the first 2, group the last 2. And we're going to look for what we can take out of those. We can take a 3n out of the first group, and we are left with n minus 3. The second group, we can't take anything out, so we just put a 1 there. When you can't take anything out, you pull out a 1. And we also have n minus 3. And that's how it always should be when you factor by grouping. You should have that same group left. So n minus 3 is one of our groups, and then 3n plus 1, if you'll remember, is how we factor these from last chapter. And now it is already factored for us. And so we are going to set each factor equal to 0. N minus 3 equals 0. 3n plus 1 equals 0. And then we are just going to solve. So add your 3. N can equal 3. Here you have to do 2 steps. Subtract 1. You have 3n equals -1. And divide by 3. So you have that n can equal 3. And n can equal -1/3. And so those would be our answers here for that one. 3 and -1/3. Concept is the same, factoring is just a little bit different. For the last one, you will notice it is not equal to 0. So we're not even going to start factoring first. What we're going to do first is we're going to make this thing equal to 0. And we are going to do that by just adding that 6 over, or if it was a positive, we would subtract it over. So we're going to add the 6 to both sides. Line it up under the constant. That's what you're going to add it to. All right, so on the right-hand side, -6 and +6, we will have our 0. On the left-hand side, the only thing that changes is that constant, your c. So we have p squared plus 2p, and then we have -14 and +6. What am I going to get with -14 and +6? -8, right? And now I'm looking for factors of 8 that give me 2. All right, one's going to be positive and one's going to be negative. So we're going to say p plus 4, p minus 2. 4 and -2 multiply to give you -8, and they add to give you +2. And then we are just going to set those equal to 0. P plus 4 equals 0. P minus 2 equals 0. Once we do that, we're just going to solve. Subtract your 4, add your 2. So P will equal -4 or +2. And that would be your answer here. 4, -4, +2. Questions on that? Plus or minus the square root of b squared minus 4ac all over 2a. That is your quadratic formula. You have to have that because you are going to have to solve with the quadratic formula. You'll have 4 with factoring, 4 with quadratic formula. These are the different types of the ones with the quadratic formula. You do not have these. These are ones that I just pulled so that I could show them to you. The first type is just straightforward. It has your A, B, and C set up for you. So your A is 2. Your B is -7, and your C is a +5. All right? And so we're going to do the quadratic formula here. Negative B, it is already a -7. So I'm going to change the sign to 7 plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Once I have that, I'm just going to simplify. All right, so I end up with 7 plus or minus. What is -7 when I square it? 49 minus 4 times 2 times 5. 4 times 2 is 8. 8 times 5 is 40. All over 2 times 2, which is 4. I have 49 minus 40 in there, so I'm going to simplify that to be just 9. 7 plus or minus the square root of 9 over 4. Does 9 have a perfect root? Yes, it does. What is the perfect root? 3. So I have 7 plus 3 over 4. 7 minus 3 over 4. What is 7 plus 3? 10. So I end up with 10/4, which I will reduce. 7 minus 3, 4/4, which I will reduce. All right, so 10/4, what can go into 10 and 4? 2. So I have 5/2. 4 divided by 4 is 1. All right, those are my answers, 5/2 and 1. All right, that's one of the ways that you can get an answer here. It can be just perfect numbers that end up to be a whole number or a fraction. All right. That's one of the types of answers you can get. All right, look at number 6, the other type of answer you can get. For number 6, we're actually not going to be able to come up with a perfect root. We're going to do the quadratic formula the same way. Negative b, which in this case is 3, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. In this case, when I simplify, -3 plus or minus the square root, 3 squared is 9, minus 4 times 4 is 16, times -2 is what? -32, right? All over 8. So I end up with this number, -3 plus or minus 9 minus a -32 is 9 plus 32, which is 41. Does 41 have a perfect root? No, you will leave your answer just like that. That is your answer. -3 plus or minus the square root of 41 over 8. You are finished. So you're going to get the same types of answers for 7 and for 8 as we did for 5 and for 6. But what do you notice about these two problems that's different? It's not equal to 0. Just like with factoring, quadratic formula must be equal to 0 before you start. So for these problems, I would subtract the 4 first, line it up directly under that whole number, and you have a squared plus 8a, and then 11 minus 4 is what? 7. Now, I know you can solve this one by factoring. I get this. However, in my instructions, said solve by the quadratic formula. So I actually force you to solve it by the quadratic formula, even if you can see you can factor it. Now, as we get to the test, I'm going to give you some of these, and you will be able to choose how you want to solve it. But in this quiz, you have to solve it the way I told you. So you're going to, again, do -b plus or minus the square root of b squared minus 4 times a times c all over 2a. This one actually will work out to -1 and -7. You'll get whole numbers or integers here. But you do need to solve it by the quadratic formula. 8. Look at 8. Again, I have a problem. I have equal to 5. I need to fix that first. Subtract 5. Subtract 5. Pay attention to your positives and negatives here.
Can you just leave it at that?
No, you actually solve it. When you solve this, you get -1 and -7. So you will get a final answer there, but I was just walking you through how to set it up. All right, this particular one is not factorable. There are no factors of 11 that subtract to give you 3. So in this case, the only way to solve this is the quadratic formula from the methods that we have learned. And so once again, you'll do the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And when you simplify this one, you will leave it in radical because this one ends up being the square root of 53 when you simplify that radical there over 2. So those are the two types of answers you will get. Those are the two types of problems you will have. You will have problems equal to 0, problems not equal to 0. And you will have 4 of these on your quiz tomorrow. 2 of each, just like it's shown up here.